Hi, ladies and gentlemen. This afternoon, I just want to address something we've been talking about in class that I know some students have been struggling with. And I just wanted to go over this concept in a different way, and hopefully it will shed some light because I know this is a concept some of us have been struggling with. And this is activation energies of chemical reactions and why a reaction is exothermic or endothermic, okay, and what the result is. So if we look over here, okay, we did talk about change of state versus change of temperature before. And when heat is entering into a system, it'll actually cause an increase in temperature of the system. But if we're working with a substance, let's say that is a solid, once we reach the melting point of the substance, let's say ice, you get to a point where it is changing state. And during the point where it's changing state, the temperature of the substance does not change. And the reason for that is because instead of the energy going towards changing the temperature, it is actually going towards changing the state of the substance. So it is going towards breaking the bonds between the water molecules, for example, so that it can go from a solid to a liquid. Okay? Now, the reason I bring this up, okay, as you can see, while that change is occurring from a solid to a liquid, there is no temperature change. We're going to apply that same principle here. Here, this is an example of a substance that requires a larger amount of energy to initiate a chemical reaction. So if I'm doing this reaction in a test tube, let's say, it is pulling energy from its environment. The molecules are pulling the energy from the liquid that it's in. It's pulling energy from the glass, from the environment just outside the glass, and it's pulling that thermal energy to increase the energy of the system so that it could trigger the reaction to happen. Once it triggers the reaction to happen, okay, the substance undergoes the chemical change and it ends up at its final energy state, which is right here. Well, if you look here, this is the activation energy right here. Okay. This is the energy that was absorbed. Now, most people think if you're absorbing energy, you're increasing in temperature. It is the opposite here. It's absorbing energy so that this chemical reaction can physically take place. Okay? Much like here, this is absorbing the thermal energy that's being put in the system, but it's working towards changing the state, not the temperature. So just like that, in this case, the energy is being utilized for the purpose of forming the chemical reaction or for the chemical reaction to occur. It's needed for that reaction to take place. Therefore, it's absorbing all this energy, but it did not release the energy back to that environment. Well, what happens when we pull thermal energy from our environment? The environment becomes cold. So the liquid the chemical reaction is happening in, the glass of the test tube that the liquid is in, all of that, the external environment just outside the test tube, thermal energy was pulled away from that so that the reaction could occur. Therefore, the test tube feels cold. And this is called an endothermic reaction. Energy entered into the system to cause a chemical reaction to occur. The external environment of the test tube feels cold to the touch. Now looking over here, this is the energy state that the reaction starts with. It does not need to absorb as much energy. So this is the activation energy here. As a result, once this chemical reaction is triggered and it happens, it releases a large amount of energy as it lowers its energy state. Well, all of this energy, after the energy it took from the environment is returned, this is all of the energy released. Now, when that chemical reaction releases that energy, it releases it into the surrounding environment. Well, what's the surrounding environment? The liquid the chemical reaction is happening in. The test tube the chemical reaction is happening in. And as a result, when that liquid in that test tube gets hot, the immediate surrounding environment, the air. And when you hold that test tube, your hand will get hot. You will feel the heat that chemical reaction is releasing. So I know it's a little bit confusing, and by this way, this is an exothermic reaction. It is releasing thermal energy. So I know that it can be a little bit confusing, but in this case, the energy is not going towards changing the temperature of the system. It is going to perform a task, in this case, to trigger a chemical reaction. So here, while it's not releasing the same amount of energy, it's releasing less energy than it absorbed. Here it's releasing a lot more energy than it absorbed. It is heating the test tube in the surrounding environment. This is removing the energy from the test tube and surrounding environment. So this will feel cold and this will feel hot. I hope that helped you understand that question a little bit better and the difference between an endo and exothermic reaction. And if you have any questions, don't forget, tonight at 7:30 is my Twitch. And I will see you then.